Hi everyone, I'm Ryan Blue. I work for Netflix. We've been here at Spark Summit for the last couple of years talking about sort of how we've made reliability and S3 better. And today we're going to talk mostly about our work inside Spark, how we've been working to improve the reliability of Spark across data sources. So not just our S3 table format, but all of the sources that you can interact with. So first off, I'm going to give a little brief primer to data at Netflix. The idea here is just to set up like, what is our motivation, how are we using this stuff, and what are the challenges and problems that we come across. So Netflix, for I guess pretty much the entire time that we've had a big data team, has tried to build a cloud-native data warehouse. And a cloud-native data warehouse looks very different, or has looked very different in the past from the on-premise clusters or even long-lived clusters that most people use even in the cloud. So at Netflix, all of our clusters are Yarn. Well, I guess we have other things, but those aren't the subject of this talk. What I'm primarily talking about are Yarn clusters that are expendable. So if anything happens to our clusters, if we lose a name node, we don't have name node failover, we bring up another cluster, move the workload there, and really take advantage of that elastic compute resource. This is a lot of benefits that I think we've talked about in the past. So I'm not going to go too much into it, but it is so nice not to worry about wire compatibility in Yarn and things like that. So we think that this is probably the architecture that most people will adopt in the future. That said, expendable clusters really require a lot of architectural changes. So you have to have some tier where job submission happens to pick which cluster this should run on, because you can't configure jobs to know about that ahead of time. You also need things like a cluster-independent metastore, which we've built, we call Metacat. And the one that affects most of our talks like this and is pretty much our motivation for the talk today is that S3 is the source of truth for all of our data and has been for like the last 8 years. But S3 is eventually consistent, which means the file call, listing calls are inaccurate, which wreaks havoc with Hive tables because they keep state about what's in your table in the file system itself. So we've had to work around this in various ways. We've talked about those ways in the past. What we need to focus on here today is that basically if you're using S3 as a source of record, sometimes your queries might be incorrect. And that sometimes is really the key, right? Because at the scale that Netflix runs, sometimes is several times a day and really wreaks havoc in the trust and reliability of our systems. So if every day at least 5 queries give you the wrong result, then people stop trusting your platform. And that's a huge problem for us, or was a huge problem for us. The trust in the platform giving people the correct answers for their queries. And this was something that we just could not continue, right? We had to work around this problem in order to build that trust with our user base that when they ask a question of our data, they're going to get the correct answer. And they don't need to run it 5 times and take the average of all the results. So we've always been really sensitive to this idea that our tables need to return correct answers. We got, I think, burned by it in the beginning. And so we went way past things like Semper that give us consistent file listings. We did a project called the batch pattern, which gives us in-place writes. And then we use Metacat to swap in new partition locations so that even if you're writing across many partitions, you get atomicity. So we either guarantee that all of your data is there and correct, or none of it was written to the table and there are no changes. And we've had atomicity for a long time. This dates back before even our work with Spark. We had this pattern working in Pig, and that's why I say this is circa 2016. This is what we were presenting on and what we were using in 2016. Around that time, I came to Netflix, and I started working on getting all of this working with Spark. Quick shout out to my, my talk in about 35 minutes. I'm going to be talking about our adoption of Spark at Netflix and how we got to 95% of our job executions running in Spark. That's going to be in room 2006 if you guys want to see that. But for the purpose here today, my first task was to integrate our S3 batch pattern committers. And I've done that across numerous Spark versions. So the first one we did was 1.6, so the very old version. This was pre-data frame and data set being merged together. It was only for the Hive path. We also did it for data source reads once they became reliable in Spark 2.0. And then we do conversions now from Hive table reads and writes to data source reads and writes using the batch pattern in 2.1 and our 2.3 line. So we've done this quite a bit. We've spent a lot of time in the write path, and we've noticed several problems and challenges and difficulties along the way. And that really informs what we've done, as well as the work that we're talking about today, the DataSourceV2 work. Because we concluded fairly early on that there were significant problems and roadblocks to just getting it all working with what we needed to do. And in the 1.6 to 2.0 transition, we forked the write path entirely. So we used the 1.6 structure of the write path for the last couple years now. And I want to talk today about why did we do that and how we're merging back in to make upstream Spark as reliable as the version that we use internally at Netflix. So what are the problems with what we have today or what we've seen in the past? The biggest one is the use of data frame writer. The behavior of data frame writer, which is basically the best way to take a data frame and write it to a table, is that the behavior isn't well defined. And it's poorly defined in a number of ways. So first of all, it's not obvious what happens. What's the difference between save and save as table, right? Aren't we working with tables? What's going on here? Can anyone tell me what validation rules are different between save versus save as table? Not seeing many hands. That was an interactive one, so please. The reality is that almost no one can tell us what the behavior difference between save and save as table is. At a high level, save just goes through and calls an arbitrary data source. Save as table pulls a data source or a table out of a metastore. But what actually happens is that these create radically different logical plans. So like insert creates an insert into that almost immediately gets transitioned into insert into data source table, insert into Hive table, save into data source table, all sorts of different things. And it's really hard to know exactly what's going on. In fact, it's so hard to know that in releasing DataSourceV2, we can't even just switch over to it. We have to really carefully plan the transition, and it will be a breaking change. Another thing that's really difficult is what happens when you say overwrite in the data frame writer API. Do we know? Turns out it's inconsistent. So overwrite could mean blow away this table and create a new one with whatever schema and data that I have in this data frame. Could mean drop all the data in the table but keep the schema and then insert the entire data frame. It might be delete some static partitions and then insert. It might be replace all partitions dynamically, We really don't know. Different code paths are past this save mode, and they do different things with it because it's not defined what save mode actually does to your data. And that's a problem. Another problem with save mode is that it delegates behavior to the sources that sources really shouldn't know about. So file sources, for example, if you use append, will create a table for you, which sort of makes sense. What happens when you append to a table that's not there? Well, you told it to write. You said, data source, save as table, append, and then, data frame, write, append, and then save as table, right? That's pretty clear that you want to create a table. But there's nothing that actually says, hey, create this table. So we have to infer your intent. And what happens when we infer the intent based on something that's very high level, like append or overwrite, is that sources each choose a different behavior. So we really have no reliable behavior because save mode is so widely used. That brings us to validation as well. So it's not just what is the behavior of create or something like that. All of these different code paths, I mentioned earlier that when you insert, you might get an insert into Hive table, insert into data source table, several different flavors or variants. Each one of those might use a different rule to validate your data frame against the table schema. So sometimes it might say, oh, this rule was written to be case insensitive or case sensitive. We've screwed that up in the past. And different rules have different behaviors. The main two are preprocessed table creation and preprocessed table insertion. Preprocessed table insertion is basically what you think it might be, right? We're taking a data frame and looking at a table and saying, okay, how do these two sets of columns line up? On the preprocessed table creation, it turns out that we can run a create table as select on a table that already exists. What the correct behavior there is kind of up in the air, but preprocessed table creation does the exact same resolution as preprocessed table insertion when the table already exists. The question is, why do we have two, and what do they do differently? And we don't really know. Then there are other sort of wonky or weird validations. So Spark will automatically insert unsafe casts. If you say, all right, take this string and put it in a Boolean column, and you do that by accident because maybe your column ordering is off and you went through a write path that happens to use column order instead of column name, then your strings will just be dropped silently, right? They will be cast to Booleans. Most of them will come out null unless you happen to have true or false values. And sorry, I guess it's string to int. Maybe Boolean's a bad example. Anyway, most of your strings will turn out null. And Spark won't tell you that that happened. Another fun fact that we just learned recently is that when you're using the save path through data frame writer, the path tables have absolutely no schema validation. So if you say, go write this data to some location, there's no validation that the rest of the data files in that location have the same schema. So this is really scary for platform teams like me. Another fun, scary quote that I found in the code base is this one. It's basically, this save as table plan and some insertion plan really should do the same thing. But we've got two, and they might have different implementations, so we should just keep them separate, right? We didn't even do the work to find out, do these things have the same behavior, and collapse them into one. So the write path really is, quite concerning at this point. Another thing I want to point out in the problems category is the use of runnable command. So runnable command is basically the high-level command that you're running. Insert into data source table command, something like that. Or in this case, create data source table as select command. The problem is, we said, we just want to take this logical plan and make it runnable. So we'll wrap it in a physical plan that is run some command, and then that command knows how to run itself, which seemed like a great way to break up the work, especially because we had all these different logical plans. The problem with that, though, is that now we have physical plans that are a single node. It is, hey, go run something from a logical plan. So we're taking instead of going from parsed plan to analyzed plan to optimized plan to physical plan, and then running that physical plan, we're actually just linking a logical plan underneath the physical plan and saying, well, run whatever's in there, which is, again, problematic. What we see here is that you don't get the physical plan information, so you wouldn't see whether you're using broadcast joins. You wouldn't see any number of things from the Spark UI itself. In fact, the only thing that we get here is that we're running a create data source as select command. We get a single node, and this has been later fixed, but it's really just been worked around to expose the physical plan at runtime. The underlying problem that we have commands within commands is still there in some cases. The last challenge I want to go into is really about some of the community roadblocks. And this is a different kind of thing. When we first looked at moving from 1.6 to 2.0, we were fixing some of these problems in the Spark community. We'd identified the different validation rules that were going on, and we were scratching our heads and asking questions. And this was just before the 2.0 release. And we got a lot of pushback from the community, just a few community members in particular. We were pinged on a review 2 days after the change had been committed and backported into the 2.0 release branch. It included things like parts of our PRs that were committed without attribution and things like that. So this was one of the reasons why we ended up going and forking the right path. So I do want to just address the community issues here. We have since followed up individually with the committers in question. We don't want to just let this hang out there. And we've seen a lot of improvement and progress in this area. But I do just want to say, I'm an Apache member. I care very deeply about making these communities function properly. And this sort of behavior really, Netflix didn't really contribute to Spark in a substantial way for like a year and a half because of this. So if you guys hit these types of problems, please email me. We will address them because it's super unhealthy for the community, and we don't want to lose out on any contributions because of this kind of negative behavior in the community. So please reach out to me directly, and we will definitely address it. But this happened, and we basically said it's not worth our time at this point to contribute to Spark. So what changed about that? Basically, what changed about this is we made a couple realizations. First of all, we were doing this reliability thing wrong. What we realized at Netflix was that our approach was a series of band-aids on different problems. So our approach was make file system listing calls consistent, even if that's a crazy idea and is really expensive. Take other file system calls and break the file system contract because it's just too slow. Other things like the batch pattern introduces overwrite by default, which our users were constantly confused about. And what we did in, I guess, early last year was we took a step back and said, maybe the file system isn't the problem, right? Maybe we're doing the wrong thing by having all these band-aids. What we should be doing is redesigning the reason why we have listing calls that determine what data is in the table, right? We should be treating S3 as an object store and building off of that instead of patching the file system and trying to accumulate these workarounds over time. So what we did is we took a look at why we were doing all these crazy things, and it turns out that it was Hive tables. The way we store information in Hive tables just needs to be redesigned for cloud-native storage. So that's what we took on, and we built Iceberg. And while we were doing that, that's why we call Iceberg tables without unpleasant surprises. While we're integrating and basically rebuilding this lower layer in the storage system, we decided, hey, we can actually fix a lot of these persistent usability problems at the same time. So Iceberg fixes schema evolution by using an ID-based system so that you can always rely on your Iceberg table having the same schema evolution rules that you use in normal database tables. Pretty cool. Even if your schemas are deeply nested. We also said a lot of our problems come from users screwing up partitioning, either on the write path, where they have to know how to take a timestamp and convert it to a string, so that we can store these things by date. If you're doing this, what time zone do you use for that? And if you put that in the wrong category or in the wrong partition, then we're going to miss that data later. And our tables, even though it's a user problem, our tables are going to lie to us. So what we want to do is take that responsibility out of the user's hands, just like we take the responsibility for pruning these partition columns out of the user's hands. If we do that, then the tables just work, as long as you configure them for whatever partitioning scheme you want. So that's another thing that Iceberg does to sort of modernize our data infrastructure. And the last thing I want to mention here is just we want to look at things as configuring tables and not configuring jobs. If we configure jobs, then we have to know how to configure every single job. And when we move from Pig to Spark, we have to know how to translate all of those different configuration options in order to get the data written correctly. What we're doing is we're moving to a model where we want to configure tables so that you don't have a job-wide target split size. Your target split size should be per table for the data in that table and things like that. So this is where we're heading in 2019 for a reliable data warehouse and a usable data warehouse. And that was one of our primary motivations for taking on this DataSourceV2 work. So we needed a way to integrate Iceberg very cleanly with Spark. We also had grown pretty tired of maintaining our own write path. It's a lot of work to maintain a write path, and every time we want to pull in a new Spark version, it takes a couple of weeks to a month to make sure the write path is working the way that we intend, right? Because Spark changes a lot in every release, and it's really difficult to go port that off over to a new branch. Another thing is that Spark's write path has solidified somewhat in the 2.0 line, or 2.x line, sorry. So it was really unstable and kind of concerning in 2.0, but now that we're at 2.3, 2.4, it hasn't been changing all that much, and we think that it's matured enough that we can step in and really do this work. And the last thing was that DataSourceV2 was proposed, and we said, hey, this is a great opportunity to get off of our own write path and actually fix some of these problems in upstream Spark that we want, that we're very opinionated about. So, why DataSourceV2 though? Wasn't this just a project to use internal row or a better representation for data and like sort of improve V1? That was just a read and write API, right? Unfortunately, no. And this is where the save mode abstraction has really caused problems in DataSourceV2. So DataSourceV2 inherited a lot of these things from V1 that are problems. The use of save mode in order to do things like create table as select. Here's a save mode. If the table doesn't exist, do what you're going to do, right? We don't want sources to make that determination because that's not reliable behavior. If the table doesn't exist and you said create table as select, that's great. If the table doesn't exist and you said append to it, then you can't insert into a table that doesn't exist. You haven't given us a schema. So we want Spark to work just like any other database engine, and in order to do that, we need to fix DataSourceV2. Another thing is, I mentioned earlier the proliferation of all these different logical plans that do essentially the same thing. that caused V2 to have no write validation out of the box. So we just forgot about it. It was yet another logical plan, and no one said, oh, hey, when we add this logical plan, we have to remember to add the validation rules that check the schema of the table versus the schema of the data frame you're inserting. So we just didn't have it. So this became a really great opportunity, in our opinion, to improve Spark without actually needing to build a V3 in 6 months. So what are we doing differently? This is really the good part of the talk. In V2, things are going to get substantially better. So what we've done is we've taken a look at all of the operations that users actually call and the patterns of behavior that they expect to be there. This is primarily based on SQL and Hive syntax that we've supported for a very long time. So you can do things like insert overwrite, insert into, create table as select, and things like that. We've also looked into different variants of these that users may expect. So where before we had some sources with overwrite mode replacing the entire table, we said, well, maybe that's a use case that we should support. If you want to legitimately just blow away this table and replace it with the contents of a data frame. So that's where we got replace table as select. So we've done a good job of figuring out what these common logical plans should be. And we've committed in the community to this SPIP, which says we're going to standardize on these plans. We're going to use the same set of logical plans for all operations, or at least all batch operations at this point, that Apache Spark uses. So with that, we can document user behavior and expectations, and things like create table as select won't be dependent on whatever the source happens to do. It will be that for every table, if the table doesn't exist, we can continue. If the table does exist, we simply fail. We can't do that. I may have already covered this. Okay, so yes, we are specializing on physical plans, not logical plans. This is basically saying that we want all of the logical operations that are inserts to go through some insert path and be validated in the exact same way. We don't want to just forget to apply the rules to a new logical plan and put that in a release. We also want to apply the same rules universally. So append and overwrite should not only be the only way to do that operation, but they should use the same validation rule so that we have consistent behavior across plans. And we're going to avoid using runnable command because that's caused some problems. The problem with that, though, is that we quickly realized we needed to, in order to get consistent behavior, we needed to interact with the source of truth for tables. So this is something that Spark has historically just sort of punted on. The metastore, as it is today, can wrap third-party tables and make it look like it's a table, but really it's a JDBC connection that is just metadata sitting in Hive metastore or something like that. But if we want to truly run create table as select in a JDBC database, we actually have to go talk to that JDBC database and say, hey, create a table. So we quickly realized that in order to have this consistent behavior between file sources, Iceberg sources, and things like that, as well as JDBC, Cassandra, et cetera, we actually have to be able to query and say, does this table exist? Create that table, drop that table, and we need all of those for things like CTAS. When we create table as select, we need to know if it exists to fail if it does. We need to create the table, insert into the table, and if anything with that insert went wrong, we have to roll it back because users expect create table as select to either work or produce no table at all. So this, unfortunately, requires a catalog plugin API, which we've luckily also standardized through an SPIP, Spark 27067. And then as we were doing that, we realized that if we're building a catalog API, we should probably make sure it's going to work for multi-catalog support. So we've gone from, this is a very simple read-write API. to we're going to replace all the logical plans to make them consistent, to we're actually going to have multi-catalog support in Spark. And oh, by the way, to do that, we have to decide what identifiers mean. And that's the last SPIP. What identifiers actually mean for multi-catalog support. So we've actually expanded quite a bit what DataSourceV2 means. The nice thing about this is that hopefully by Spark 3, we're going to have at least a working 100% there set of logical plans that in the future we should be able to standardize on. I think this is going to be really good for Spark in the long term, but it is pretty painful now because this has to be independent of the V1 path. We don't want to break any existing V1 jobs, and as we've said earlier, V1 behavior is consistent across versions, but it's not consistent across sources. So we've got to choose one set of behavior and standardize on that. That means we're going to break a whole bunch of jobs no matter what we do, so we have to make it so that when you're interacting with V2 plans, you know that, and that is sort of an opt-in situation. So we can't change the default behavior from V1. We have to allow you to call V2 itself. The SPIPs have, though, been adopted, and we're on track, I think, to get this work into Spark 3. We have append and overwrite plans already in. We have validation rules in, and we're just waiting on getting the catalog API committed before we can add all of the DDL operations, like create table, alter table, et cetera, as well as create table as select and some of the higher order functions, or not functions, higher order operations. And with that, I went 2 minutes over my goal, but thank you so much for listening to me about DataSourceV2. I did want to leave plenty of time for questions because there's a lot of moving parts here. So if you would ask questions from either this mic or this mic, and thank you for coming.
Hey, thanks for all the work. I actually just encountered this problem yesterday, so I know that currently right now a lot of behaviors are a mess, and then a lot of people getting surprises. But my question is there a plan to actually adding a static partition insert in DataSourceV2? Basically, that actually will boost the performance a lot when you're actually inserting into a Hive table. Right now, what we do is that we actually create a temp view on the Hive table and then craft a like insert into SQL query and then do all those stuff. There will be a API support from Spark for that.
I'm not quite sure what you mean by a static insert.
So basically, when you insert into a Hive partition, you actually use static partitions. You don't enable the dynamic partition insert.
Do you mean from the DataFrame API?
Yeah, from the DataFrame API.
So one thing I didn't talk about that this reminds me about is I think that we actually need to replace the DataFrame writer API because it's ambiguous, it's confusing, and that's what you're talking about. We actually plumbed this through in Netflix's version pretty easily because all you need to do is say, okay, hey, take this column name, set it to this literal value, right, to do that static insert.
Yes.
I think that we could definitely do that in we could possibly do that. The reason why is I don't really want this API to know about partitions per se. So maybe what you should be doing is saying this column is a literal value for your static insert instead of like having a different syntax for doing that.
Okay.
Right,
yeah.
like with column A, literal 3, right?
Okay, thanks.
Yeah. But along those lines, I really do think that what we want is a clearer data frame write API. So what we've talked about is an API that gives you verbs that correspond to the SQL verbs that you see all the time. So overwrite for insert overwrite, create for create as select, insert or append, something like that, and so on. Like you should have very clear verbs that indicate exactly what logical plan the right API creates. If we do this, then there will be a really strong correspondence between the data frame write API and SQL, which is what we want. We want all of these operations to be very clear if you're calling them. Not just like, take this and save it. I don't know what's going to happen to the rest of the data in this table. We also, along those lines, we want to move to a situation where you're actually specifying what to overwrite. The implicit overwrites, like dynamic overwrites used by Hive, I think are really unhealthy for the community in general, because you're just saying, okay, take this data and replace whatever it conflicts with. At what granularity? Day, hour? It depends on the partitioning. Again, we're bringing partitioning into the correctness or behavior, and we probably shouldn't do that. Partitioning should be an optimization that we use for your table. We have a question. I don't know who was first.
Hi. So we've tried to use the DataSourceV2 for our own internal format, and we've run into a few issues, especially around like the write API on DataSourceV2. I was wondering if you had any experience with that or could talk about any future improvements to that.
Yes, so we have as well. In our internal version, we've actually built out all of the SQL plans that we're talking about here. And our goal for V3, Spark 3.0, is to get those upstream into the community because it's very difficult to work with it. Right now, the only way to exercise the V2 code paths is through save, right? DataFrameWriter.save. I would love to see that new DataFrameWriter API in Spark 3 if we can. That's a stretch goal. As well as all of the SQL plans so that you can do create table select, insert into, insert overwrite, et cetera, and have the standardized behavior for V2 tables.
So with respect to the table metadata parent ticket you referenced, 27067, or yeah, 27067, do you know if the Hive bucketization concept is becoming a first-party concept in that metadata?
Oh, good question. My goal is to make bucketing a first-class citizen. Now, what we're doing is trying to change partitioning so that it is a transformation of table columns and not just like extra columns. And bucketing would be a transformation, right? So you would say, instead of a bucket by clause, you would partition by column A, column B, and some bucket function of column C. The benefit to doing that is we've expressed a way for you to say, bucket this data source, and for the data source to communicate back that it is bucketed. And we're also working on an API for getting functions from those catalogs that manage these tables. So what we should be able to do is go read a table from a catalog. Oh, it says it's bucketed. Hey, give me the bucket function for that catalog. And then once we have that bucket function and a bucketed table, we can use that to prepare the other side of a join and do bucketed joins. So that's our long-term plan. I doubt that's going to be, like 3.0. That's like 3.1 territory. But at Netflix, we're really interested in getting those bucketed joins done. So we're going to push on that.
Oh, thanks for the nice talk. We realized that Presto and Spark have Hive dependencies, and where does Iceberg fit inside? If Iceberg also need Hive dependency, or how would various Hive versions work with Iceberg?
Oh, okay. So Iceberg question. Iceberg, we're building support in Spark and Presto. There's no reason why it couldn't be integrated into Hive, but Netflix has no interest in doing so.
Okay, thank you.
And that's all the time we have for questions. I'm sure Ryan would be happy to take your questions after his next talk in 10 minutes. Thank you.
Yep. Thank you, everyone.